So we have many derived quantities. Earlier we talked about speed, acceleration and force. But our derived quantity is much more than that. Let's take a look at this table. For instance, we have area, whose unit is square meters. We have volume, which is cubic meter, meter raised to power 3. That is length in 3 places. We have frequency in hertz. We have mass density, which is the ratio between mass divided by volume. That's why the unit is kilogram per cubic meters. The kilogram is the mass divided by the volume, and the unit of the volume is cubic meters. Then we have speed, velocity we mentioned earlier. We have angular velocity. We have force. We have pressure. We have viscosity. We have quantities. We have so many of them, and you can all find them in your courseware. So let's take a look at prefixes for SI unit. What do we mean by that? Of course, we mentioned that to express very large and very small quantities we often run into in physics, we use scientific notation which employs powers of 10. So what do we mean by that? Let's take a look at this table. For instance, we may have mass in millions, numbers of decimal places, or we may have length in meters, but in thousands of places, much more than that, many decimal places. So one way to do that is to compress these numbers into a factor of 10. For instance, we could have, as you can see on the screen, for example, we have this number to represent our meters. So we can put this in a standard form by counting the number of zeros that exist in this number. Let's take, for example, this can be written as, let's do this together. So let's count the number of zeros to the left. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So the number of decimal places here becomes 7.56 times 10 raised to power 9 meters. This 10 raised to power 9 has an equivalent prefix called giga, and that becomes 7.56 gigameters. And when it's 10 raised to power minus 9, we call it nano. Will be nanometer. The same applies to these numbers of seconds that has a lot of decimal places. So we'll count to the right. Let's do it together. We have 1, 2, 3, 4, 5, 6. So we can stop here as 5.46 times 10 raised to power minus 6 seconds, which is the same thing as dividing 5.46 divided by 1 million. So in other words, 10 raised to power minus 6, as we can see on the prefix table here, is equivalent to micro. So we can therefore write as follow: 5.46 microseconds. So the mu here signifies micro. So this is a way to use scientific notations for a very large number representing any physical quantities. We also have unit conversion. Sometimes there is a need to convert the unit in which a physical quantity is expressed. As we see on the screen, we can convert between minutes to seconds. So we use what we call a conversion ratio, or we implement a method called chain link conversion. In this method, we multiply the original measurement by a conversion factor. When we mean a conversion factor, we mean a ratio of units that is equal to unity. Please take a look at the screen. For example, we know that 1 minute and 60 seconds are identical. They are identical because they are of the same time interval, only that the units are different. So therefore, we can use 1 minute divided by 60 seconds to be equals to 1. and at the same time 60 seconds divided by 1 minute is equals to 1, because since they are the same, we equate them to be equals to 1. X divided by x is 1. But this is not the same as writing 1 divided by 60. 1 divided by 60 will not equals 1. This is what we call a conversion factor. This is 1 minute divided by 160, or 60 seconds divided by 1 minute. So if we are to convert from any given quantity to another, once we can understand or we can determine the conversion factor, then make use of chain link conversion method. Let's give an example here. Suppose we are asked to convert 5 minutes to seconds. So we write 5 minutes. What is the conversion factor between minutes to seconds? Earlier we said the conversion factor could either be 60 seconds divided by 1 minute. In another instance we said 1 minute divided by 60 seconds. So in this regards, which one are we to use? Since we are converting from minutes to seconds, we need to look for a conversion factor that can eliminate the minutes and give us seconds. So if we have a conversion factor like so, 60 seconds divided by 1 minute, that is a conversion factor. This eliminates the minutes to give us our seconds, and 5 multiplied by 60 give us 300 seconds. Okay, let's say for example we are now to convert 300 seconds to minutes. What will be the conversion factor? Since we are moving from seconds to minutes, and we understand that there is a conversion factor that could be either 60 seconds to 1 minute or 1 minute to what? 60 seconds. And we know that both are the same because they are unity. Then we want to eliminate the seconds to give us minutes. So which among these two do you think we can use? You can pause the video and tell me. Okay, so we have this 300 seconds multiplied by the conversion factor that can eliminate our seconds. And what will be that? That is going to be 1 minute divided by 60 seconds. So the second cancels out and we are left with what? Minutes. So if we divide 60 divided by 300, will give us 5 minutes. So we have successfully converted from 5 minutes to seconds to give us 300 seconds, and at the same time converted from 300 seconds to minutes. That is 5 minutes. Let's consider another example. If the weight of your class representative is 7,000 grams, you are asked to convert this weight from grams unit to kilogram. So I said the first thing to determine is the conversion factor. What is the conversion factor between grams to kilograms? So we have here, let's write it here. We know that 1 kilogram is equivalent to 1,000 grams. Or we can write 1,000 grams is equivalent to 1 kilogram. So the most important thing is that we want to eliminate the gram as given in the question. So we write 7,000 grams multiplied by the conversion factor. So here comes the options again. Are we to use this one or this one? You can pause the video and select the appropriate conversion factor that applies to this problem. Alright, so the right conversion factor will be any conversion factor that will eliminate the gram to give us kilogram as the question requires. So we multiply 1 kilogram divided by 1,000 gram. So you know what's going to happen? Grams cancel gram, and now we are left with kilogram. And 7,000 times 1 is 7,000 divided by 1,000. So our final answer is what? 7 kilogram. So good. We are moving. So let's look at other conversion factor other than the one we have mentioned. We have many of them in your courseware. So here I've only selected very few. We have for plane angle, the conversion factor between 1 degree and radian is 1.745 times 10 raised to the power minus 2, and to 1 revolution is 2.778 times 10 raised to the power minus 3. Let me zoom so that you can see the table much clearer. And we can at the same time convert 1 degree to minutes and so on. So let's look at the solid angle. One sphere is equivalent to 4 pi steradians, which is equivalent to 12.57 steradians. How about length? We have centimeter. Let's zoom in. We have 1 centimeter is equivalent to 1 divided by 100 meters. That is 10 raised to the power minus 2. And 1 centimeter also can be converted to 10 raised to the power minus 5 kilometer, even down to inches, 0.3937. 1 angstrom, which is going to be a very familiar unit that you should all be familiar with, is equivalent to 10 raised to the power minus 10 meters. And 1 Fermi is equals to 10 raised to the power minus 15. If you recall, I said 1 meter is equivalent to 10 raised to the power minus 6 micrometer in the earlier part of the lecture.